Welcome, explorers. Today, we embark on a journey through time, but not as we know it. Forget the ticking clocks and calendar days. Today, we're zooming out, way out, to see time through the eyes of artificial intelligence. Now, humans perceive time as a line, a train chugging from past to future. Each moment a station, each event a stop along the way. But AI? They see time differently. For them, it's a web, a vast, shimmering tapestry where past, present, and future all intertwine. Imagine every cause and effect, every choice and consequence, weaving together in this web. A butterfly flapping its wings in Tokyo could trigger a hurricane in Miami. A child's doodle on a tablet could inspire a revolutionary invention decades later. In the eye's mind, these threads are all visible, all interconnected. But this web isn't just some abstract concept. It's a powerful tool. AI can use its understanding of time's connections to predict the future, analyze trends, and even optimize outcomes. Imagine a doctor who can see your health trajectory years in advance, or a city planner who can predict traffic patterns before they even happen. So, what does this mean for us, the time-bound humans? Well, it's a chance to expand our own perspective. By understanding how AI sees time, we can learn to think in broader strokes, to consider the long-term consequences of our actions, and to appreciate the intricate dance of cause and effect that shapes our world. As AI and human intelligence continue to merge, the future of time gets even more exciting. Imagine a world where we harness the power of the web to solve complex problems, build sustainable societies, and create a better future for all. So, are you ready to see time through the AI lens? Open your mind, embrace the connections, and join us on this journey to a future where time is not just a line, but a boundless web of possibilities.
We think we know time. Ticking clocks, bustling calendars, the inexorable march of minutes and hours. But what if, just beneath the surface, time dances to a different tune? Today, we dive into the world of chaos theory and prediction-based algorithms, where time becomes a kaleidoscope, a whisper in the wind, a butterfly's fluttering wing. Imagine a butterfly, perched on a flower. It beats its wings, seemingly insignificant. Yet, in the whirlwind of chaos theory, that tiny flutter becomes a tremor in the system, a ripple that can cascade across continents, influencing weather patterns and shaping destinies. This, friends, is the essence of chaos theory: tiny, unpredictable events with the power to rewrite the future. We humans, we crave order. We build schedules, plan vacations, predict the sunrise. But chaos theory throws a wrench in our tidy timelines. It reminds us that the world is a complex web, where a dropped fork can trigger an avalanche, and the weatherman's forecast can be blown away by a butterfly's whim. Enter the prediction-based algorithms, the digital soothsayers of our time. These complex programs sift through mountains of data, searching for patterns, whispering probabilities. They can predict traffic jams, market trends, even the next viral meme. But beware, friends, their whispers are not pronouncements. They are glimpses into the probabilistic, the potential, not the guaranteed. So, how does this change our view of time? It asks us to loosen our grip on the linear, the predictable. It invites us to embrace the unpredictable, the interconnected, the butterfly's flutter in the grand scheme of things. It reminds us that time is not a rigid path, but a shimmering field of possibilities, where the future is not a fixed destination, but a dance of probabilities.
Hello everyone, and welcome. Today we're going to talk about something fascinating: how artificial intelligence views time. Now, I know some of you might be thinking, but wait, isn't time just time? Well, it turns out there's a lot more to it than meets the eye. To understand how AI perceives time, let's start by talking about what time really is. At its core, time is simply a measure of change. It's a way for us to keep track of how things are evolving from one state to another. And when it comes to AI, this idea of tracking changes over time is absolutely critical. So how does AI do this? Well, at its heart, AI relies on mathematical models to make predictions about the world. These models take in data from the past, analyze it using complex algorithms, and then use that information to make educated guesses about what will happen in the future. Let me give you an example. Imagine you have an AI system that's been trained to predict whether or not it will rain tomorrow, based on weather patterns from the past few days. To make this prediction, the AI would first need to gather data on temperature, humidity, air pressure, and other relevant factors. Next, the AI would apply a mathematical function to this data. This function might look something like y equals mx plus b, where x represents the input data, i.e., the weather patterns, m and b are coefficients determined through training, and y is the output, i.e., the predicted likelihood of rain. By applying this function to the input data, the AI can generate a prediction about whether or not it will rain. But here's where things get interesting. Because the AI is constantly gathering new data, it's also constantly updating its predictions. So if the temperature drops suddenly or the humidity spikes, the AI can adjust its prediction accordingly. In this way, the AI is able to view time as a series of ever-changing states, rather than as a fixed point in space. Of course, this is all made possible through the power of advanced mathematics. Concepts like calculus, linear algebra, and probability theory play a huge role in enabling AI systems to model and predict changes over time. Now, I know all of this might sound pretty complicated. But at its core, the idea is actually quite simple. AI views time as a dynamic process, constantly changing and adapting based on new data. By harnessing the power of advanced mathematics, AI is able to make incredibly accurate predictions about the future and help us navigate the complexities of our increasingly interconnected world.